Hello friends, in this video we're going to be solving this equation. So the equation says 8 raised to power x is equal to 4 raised to power x plus 2 raised to power x. Now the first thing we're going to do here is to express 8, 4 and 2 as a power of 2. 2 is already expressed as a power of 2, but let's express 8 and 4 as a power of 2. Now let's do that. 8 can be expressed as 2 raised to power 3. Because 2 raised to power 3 is 8, then I'm still going to have the exponent of x. This is equal to, what about 4? 2 raised to power 2. And then we still have the existing exponent of x. And then this is 2 raised to power x. Now the next thing I want to do is to try to isolate 2 raised to power x. Just make sure that it is separate from the other exponent. So here's what I'm going to do. One of the laws of indices says that if you have a raised to power, let's say x bracket y, this can be rewritten as a raised to power y in bracket x. So I just switched the position of the exponent. If you multiply x and y here, you get xy. If you multiply y and x, you get xy. So they are what? Commutative. So that's what I'm going to be doing here now. 2 raised to power 3 all raised to power x. I am going to write it as 2 raised to power x in bracket and with the exponent of 3. The same thing here, 2 raised to power x in bracket with the exponent of what? 2. And here 2 raised to power x. Now if you can see, we have that 2 raised to power x is constant, is present in every term. Now to make this a little bit simplified, I'm going to say let p be equal to 2 raised to power x, so that I will have an equation that will be much simplified. So I'll say let p be equal to 2 raised to power x. And if that's the case, I will now have p raised to power 3 is equal to 2 raised to power x is p, like I said, p squared, and then plus what? This is what? P. So let's move all the terms on the right hand side to the left hand side. It's going to be p raised to power 3 minus p squared and then minus p, all is equal to what? 0. If you look closely, you will see that p is constant in the first, in the second, and in the third term. P is common. I'm going to factorize p now. So let's factorize p. P bracket p goes into p cubed, you have p squared. P goes into p squared, you have p. And p goes into p, you have minus 1. All is equal to what? 0. So we have p and everything you have in this bracket being multiplied together to give you what? 0. So I'm going to be using the 0 product rule, which says that when you have the product of two values or of two factors equal to 0, it means that either one of the factors is equal to 0 or the two factors will be equal to 0. So here it means that p is equal to 0 or p squared minus p minus 1 is equal to 0. So we've already gotten one of the solutions here. How about we deal with this other quadratic equation? So let's solve this and let's get the value of p. Can I factorize this? No, I cannot factorize this. So I'm going to use the formula method to solve this quadratic equation. So that will be p is equal to minus b plus or minus the square root of b squared minus 4ac all divided by what? 2a. You might be asking, what is a, what is b, what is c? If you compare this equation with the general form of a quadratic equation, which is ax squared plus bx plus c is equal to 0. As you can see, a is the coefficient of the leading term. The leading term is the term that has an exponent of 2, while b is the coefficient of the middle term. Here this is minus p, and then c is the constant term. A will be equal to what? 1, because the coefficient of p squared is 1. B will be equal to what? Negative 1, because the coefficient of p here is negative 1. and c will be equal to what? -1, which is a constant term. So I'm going to put all of this into the quadratic formula so that I can get the value of p. Now let's do that right away. So it's going to be p is equal to minus, what is b? B is -1, so -1 like so, plus or minus the square root of b squared, that's -1 squared, minus 4 times, what is a? A is what? 1 times, what about c? C is what? -1. Okay, all divided by 2a, 2 times a is 1. So let's simplify this. P will be equal to -1 times -1 is 1. Okay, so plus or minus the square root of -1 squared is 1, minus 4 times 1 times -1 is plus 4. All divided by 2 times 1 is 2. Very good. So here we can say that p is equal to 1 plus or minus the square root of 1 plus 4 is 5, all divided by 2. So what this means is that, okay, let's call this p2. We already have p1, which is equal to 0. Let me take you back there to p1 here is equal to 0. So we have p2 and p3. All these are the respective values of p. Okay, let me take this off and say p2 will be equal to 1. I'll use plus the square root of 5 all divided by 2, and then p3 will be equal to what? 1. I will now use the other sign, which is minus the square root of 5 all divided by 2. Okay, now look at this solution closely. This will give us a negative value, 1 minus the square root of 5. The square root of 5 is going to be 2 point something, and 1 minus 2 point something will give us a negative value. So we cannot use this because it's a negative number. Recall that what? P is equal to 2 raised to x. Remember we said let p be equal to 2 raised to x. Now, if we want to get the value of x, we need to use the respective values of p. We cannot use 0 here, so we have to take this off. When p is 0, that will not work. And this one that is giving us a negative value can also be used. So the only value of p that we can use is this one here, 1 plus the square root of 5. 1 plus the square root of 5 over 2 is equal to 2 raised to power x. Now let me just rewrite this as 2 raised to power x is equal to 1 plus the square root of 5 all divided by 2. So since I'm trying to get the value of p, I am going to take the logarithm of both sides. Let's take the logarithm of both sides. So it's going to be log 2 raised to power x is equal to log 1 plus the square root of 5 all divided by 2. Okay, now this exponent of x would be used to multiply the logarithm. Okay, that's from one of the laws of logarithm. So it's going to be x log 2 is equal to, so what about this? I am going to write it like this, log, let me just wrap this in a bracket, log bracket 1 plus root 5. From the division law of logarithm, if you want to express it, let me just give an instance. If you have log a over b, this can be written as log a minus, because of division here, minus log what? B. So I'm going to be using this law of logarithm to rewrite this logarithm as, what's this now? As minus log 2. Where is it coming from? Because of this division, okay, over 2. That's why I got what? Minus log 2. So the next thing I want to do, because I need to get the value of x, I will divide both sides by log 2. So divide both sides by log 2 here, log 2 here, and log 2 here. So log 2 cancels log 2. Now leaves you with what? X, which is equal to log into bracket 1 plus root 5 all over what? Log 2. Log 2 cancels log 2, so that's minus 1. So I'm going to be using the change of base here. Since they have a common base, this one here, of course, is not written, but the default base is 10, and I want to change base. This 2 here will now become the new base if I have to use change of base in logarithm. So watch this, x will be equal to log into bracket 1 plus root 5 with the new base, which is this 2 here. That's how you do change of base in logarithm. So then we still have our minus 1 here. So this is the value of x that will satisfy the equation. Hence, this is the solution. If you enjoyed this video, kindly subscribe to this channel for more content like this. Share this video to your friends and family, and I'll see you in the next one. It's bye for now.